Hey, it's Sukrit from STEMcoder, and today we're going to take a look at the limit definition of a derivative. So, you guys all know what a tangent line is, right? We define the derivative as equal to the slope of the tangent line of a function. So, let's say we want to find the tangent line, the slope of the tangent line of a function at some arbitrary value of x. So, obviously, this point is going to be x comma f of x, and we want to find the tangent line at this point. But as you may recall, a line is defined by 2 points, right? So, well, what do we do here? Well, one cool trick is to pick another point which is extremely close to this original point over here. And that new point is separated by a distance h. So basically separated by an x distance h. And so you can see that this point is really close to this point. And we basically just draw a line straight through these to get an approximation of our tangent line. We'll call that our quasi-tangent line. So what are the coordinates of this point going to be? Well, because this distance over here is h, coordinates of this are going to be x plus h and f of x plus h. And what's the slope of this tangent line? Well, as you may recall, the slope is simply rise over run. And so we need to do y2 minus y1 over x2 minus x1. And what is that? Well, that's f of x plus h minus f of x divided by x plus h minus x, and that's just h. So, well, if we use that small perturbation, so we draw another point next to this point over here to approximate our tangent line, well, this equation is what you need to solve. This expression represents the slope of that quasi-tangent line. However, we see that smaller values of h will give us a better approximation of the tangent line, right? I mean, the closer this point is, the smaller the perturbation is, the better our approximation to the actual tangent line, our quasi-tangent line will be. So, well, that's where limits come in. So just as a quick recap, the limit of a function f of x as x approaches a is simply like represents what value does f of x approach as x approaches a. And so we're going to apply that over here. We basically want to find the value of the slope as h approaches 0, and guess what? That is another way to define our derivative. We're basically finding this expression over here, this limit. That's what we are using to find the slope of the tangent line at some value of x, and that's another way to express our derivative. We are going to be using this limit definition in the future to prove certain properties of derivatives, but just make sure you understand this right now. That d over dx of f of x is actually also equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Thanks for watching, and I look forward to seeing you in future videos.